look at the problem. Let's see if we can identify what's needed here. It says show that dy dx equals this expression. Maybe we can look at this problem and decide what method is involved if we want to find a derivative. What do you guys notice here? By the way that this is set up. Okay, definitely product rule. We see x and y squared. There's definitely involvement with product rule. X cubed and y, that's also an involvement with product rule. Those are two distinct variables that are next to each other that we can't combine, but they're being multiplied together. So product rule. What else do you see? I don't think we need quotient rule. Now, the derivative is going to produce a numerator and denominator, but this is actually kind of nice. They're actually telling you what the answer is, and we have to figure out how to connect from this to this. So we're actually just looking at this expression, right? There's no need for quotient rule at this setup because there's no denominator to worry about, right? Now, if we want to find the derivative of this expression, then that's different. But part A just says show that your answer is this. So we're actually just targeting this here. Okay, so no quotient rule, just product rule, but there's something else. What else do we need? Okay, definitely need power rule. Yeah, the y's. Hopefully the y is a giveaway, right? It's not y equals. You see y is kind of mixed into the equation there. There's a y squared as well. So it's definitely implicit. Okay, so give that a try. How many times do we have to involve product rule? Twice, right? We see two sets of pairs of variables put together. Mm-hmm.
So for this one over here, the product rule, is it negative x cubed, or do we just distribute that after?
It's up to you. You can either think of it as a plus negative x cubed, or you can have negative outside and then distribute later. Either way, your end result will have both terms being negative. So however you want to do it, the conversion is 0 to negative. So for me, I'm going to pull the negative out and just treat the x cubed and y as positives, but what you did is fine as well. We'll get the same result. So product rule here, but I'm also going to protect this second term with a set of parentheses. I'm going to let the negative be outside, so I'm going to distribute that negative through after I get through product rule. So I'm going to set everything up here. It's going to kind of feel extended because we have two sets of product rule going on here. Okay, does that setup make sense? Okay, so see how much you can fill in with in those spaces there. First, product rule. Does that make sense to everyone? Okay, so f prime, x becomes 1. We keep the y squared. Back to f. And then g prime is where we got to be careful. We got to not only find the derivative, but then attach the dy dx. Good so far? Yeah.
So we don't put the
Right. Why do we not have dy dx for this y squared?
and do the derivative.
It's not asking for the derivative. Right, it's only asking for the g. Yeah, this dy dx is specifically for a derivative notation, right? So if it doesn't call for it, then we're not going to include dy dx. Okay, second set, product rule. We're down to g prime. What is y going to turn into? Yeah, 1 dy dx, or just dy dx is fine. All right, how does that look to everyone? A quick way for me to see and make sure that I have the correct number of dy dx's pop up, look at your original equation. How many instances of y's do you see? 2. So we should be producing 2 dy dx's. Okay. We never want to rely on the derivative level to, count the dy dx's based off the y's, but you can count off of the original. The original should produce the same number of dy dx's. Okay, so now the calculus portion is done. Now we're just trying to clean this up, rearrange it, and try to get dy dx by itself. And they're telling us what it's supposed to look like. They're telling us that it should look like this. Can we rearrange everything so that it becomes this form? Okay, factor out the dy. Oh, actually, I'm going to move these terms first. Let's push all the terms that don't have dy dx's on the right side so that I can just cleanly factor my GCF of dy dx out. Okay, GCF. Okay, how's everything look so far? Pretty good. And then finally, divide the parentheses over. Yeah, it should match, right? It does. So this is dy dx. Basically, this is the slope formula for whatever this graph looks like. Kind of involved because we have multiple y's there. A lot of information is needed, so the slope formula is a little bit more involved than what we may be used to. All right, so all that is for part A. question with part A? Part B says, find all the points on the curve. The curve is talking about the original graph, whose x-coordinate is 1. Whose x-coordinate is 1. So this tells us that we're looking for locations on the graph where x is 1. So how would you approach that? So what information do I need if I want to find points? X and Y. So I have the x value. Which one? Derivative or original? Original, right? Original is going to always give us physical locations, okay? So that's our strategy for part B. Now, something that is strange about, not strange, but got to be careful with these equations is that sometimes you may have two ordered pairs, two y values for one x. And normally that doesn't happen with functions, but with these non-functions, you may have points that are directly above each other, right? Because we're dealing with graphs that are not, they're not functions. So it can break those rules and it's okay. So we'll insert 1 in for x, and we'll see what happens. So I have y squared minus y equals 6. Okay, how do we approach this problem here? Well, we can only do that if this is what? 0. So we can't do that if that's not 0. So that forces us to have to move that 6 over. This is going to be a factoring problem. We're going to bring that 6 over, and hopefully that will make it more familiar. So it looks like this is a quadratic, right? We have two solutions here. Multiplies to be -6, adds up to be -1. Y equals what?
3.
So can you tell me what are the ordered pairs that they want us to identify for part B? Good. Okay, so that's the first part of problem B. They're kind of guiding us to find those ordered pairs. We found two ordered pairs. They're directly above each other, but they are ordered pairs on this graph. All right, good so far. So now, second part, write an equation of the tangent line for each of these points. Right, an equation of the tangent line. So we have two separate points. That means we have to create two separate tangent line equations. What information do I need to find tangent line equation? So let's focus on just one point at a time. How can I find slope at this particular point? Yeah, derivative, that's my slope formula. So we'll use, it's a messy derivative, but it's still a slope formula, right? It's not as easy as f prime equals 2x minus 3, but it does the same job. It's just our graph is more complex, so our slope formula is also more complex. But we're going to need the full order pair to help us find that slope. We typically use this notation to indicate that we need to evaluate both the x and y values. So wherever I see an x and y, I'll replace with 1 and 3. What do we get here? I think it's 9 minus 9. Did you get that?
Yeah, I got it.
Okay. So 0 over 5. So what is that? What is that? That's 0, right? So basically, we have an equation that has a slope 0. So let's create that equation here. So I would say typically this is technically okay, but we can clean this up a bit more, right? The 0 is going to wipe out everything here. I get y minus 3 equals 0, so it's just y equals 3. So that's one tangent line. Are we good with that?
Wait, why'd you do 1 minus 3?
Oh, because I'm putting the point slope form. I did not write that out, but yeah. Right. Y minus y1 equals m times x minus x1. I'm filling the 1 and 3, and for the x and y, replacing the m with 0. And this is technically it's fine, but we can go a little further here, clean this up easily, get everything on the right side to disappear. We add 3 to both sides, y equals 3. No, I wouldn't. But having said that, if this was a multiple choice question and you get to this point, but your answer choice is this, then you got to find a way to get to that matching part. Okay. So there's another point, right? We have 2 points that we're trying to find tangent on the equation. So we also need to find the slope at 1, negative 2. Okay, did you guys get 2 as your slope? Any questions with part B? Right. Part C, I just want to do the setup. The algebra is a little messy for this one, but I'm more concerned about the setup here. Find the x-coordinate of each point on the curve where the tangent line is vertical. How do we approach this? How do we find where the tangent line is vertical?
So the denominator equal to 0.
Denominator of the derivative. Good. So we'll take that 2xy minus x cubed. So this is a little bit messier because I can't just solve for x or I can't just solve for y because I have two missing variables. So the approach here is you solve for one variable and then you insert it into the first equation and then you algebraically get that answer. That's more algebraically messier than I would like for us to do. So I'm more concerned about, can you get the setup right now? But technically, you know, we got to go a little further and it's going to be a lot more algebra messiness. So, but the key is the setup. If you see this, I'll give you one that's easier to where you can just solve for x or y and get to the answer rather than have to go through another algebraic step. Okay. Any questions with this problem here? Okay. We typically, so important thing is A and B, but then C, you know, it's the setup. But if this was just one variable, you'll be able to solve this a lot easier. Okay. You guys want to do another graph with product rule and quotient rule? That'd be helpful. Okay. All right. So let's go to 82. This is on page 9. So it says find p prime of 4. Build out your derivative first, and then you can work in the 4. Okay. So try that. Yeah.
Oh, on this. Yeah. Okay. So, yeah. Okay. I have a question about that.
Okay. Yeah.
So like chain rule is outside.
Right. So this is a more practical way of doing it if you have a physical problem in front of you. But we kind of force them to do it from a patient standpoint. So this is more of a conceptual problem where we have to work with the derivative from this is not it's a straightforward problem. When we get to problems where it becomes more straightforward, where the function is defined a lot more explicitly. There we go. So when problems are more explicitly stated like this, then do that outside of the
Okay.
But with F and G, we kind of have to leave it in that form, so it doesn't quite work as nice as that.
Thank you. I understood everything after that. It's just like that part.
Okay. Right. We're really just kind of following the definition of chain rule and just working through it. Okay. So 82. Okay, so 82, P of x at the top of the page is defined as f of x times g of x. So just by the way that P of x is structured, we have to be able to recognize this is a product rule problem. We go through and find the derivative using product rule first. F prime g plus fg prime. So now that you have product rule in front of you, now you can work in the 4. So we'll say f prime of 4 times g of 4 plus f of 4 g prime of 4. Are we good up to this point here? Okay. So now we can go to our graph. Okay, go to our graph. I'm going to highlight the points here. Highlight the graph at 4 so we can make it easier to see here. So I highlighted in red. So f prime of 4. F prime of 4 is asking what is the slope of the f graph? Sorry, f graph is down here. What's the slope of the f graph at 4? What would you say? Basically, what's the slope of this line segment? Yeah, we do rise over run, right? So I got to get from one point to another point along my diagonal line, up 1 over 2, rise over run, 1 over 2. So that's how I got that 1/2. Everybody good there? Any questions about that? Okay, next up, G of 4. G of 4 is asking for the physical y value of the G graph at 4. So if I look, the G graph at 4 is all the way up at 8. So there's my y value. That's my G of 4. Plus f of 4, back down to the f function. I just need to find the y value, which is 1. And then G prime of 4 is asking for the slope of the G graph. Now notice how this is meant to be a smooth transition. Okay, so we consider this a slope 0. So if we look at 81 and 82, do you see that distinction here? This has a more rounded feature. So anytime you have a rounded feature at the top, we consider that as slope 0. But if it's still a sharp, sudden change, that's not slope 0, that's slope undefined. So once we're replaced all of our function notation to be a numeric value, we can do 1/2 times 8 is 4, 4 plus 0 is 4. There's my answer. P prime of 4 equals 4. Part B, find Q prime of 7. Q of x is defined as f of x over g of x. So we go through quotient rule, replace all the x values with 7, and then we go back to our graph. Okay, so spend a minute going through part B and see if all those values and slope values make sense. Any questions? Nobody has any questions about 82? Okay, let's go to a chain rule problem. So let's go to the next page. How about number 100? Oh, you know what? Number 100, I forced it into a product rule problem. Let's see, can we do it from a chain rule perspective? Okay, yeah, let's do that. For 100, let's do it from a chain rule perspective. So on my key, I did it from a product rule perspective. Okay, so H prime of 3. Okay, don't involve 3 first. We first have to do what? Chain rule, right? Find the derivative first. Okay, so I really want us to be comfortable with function notation for chain rule, because we're going to need this to help us know what to do when we start plugging the values in. Okay, so now we can involve 3. Let's plug 3 in. Okay. What's the first thing we should do here? Look for what? Yeah, let's find a replacement for G of 3, because this makes it just super complicated, right? You got F prime and G of 3. Why don't we try to get G of 3 to be something a little bit easier to interpret? So G of 3 means I got to go to my G graph, pick out the X value at 3. Okay, oh, sorry, the Y value at 3. Oh, sorry, that's F. Okay, up here. Okay, what's G of 3 equal to? 5. Okay. So this G of 3 is going to be completely removed. In place of it, we're going to place 5 in there. Okay, do we see that substitution? I think a lot of students struggle with that substitution, so I want to see how you guys feel about that. Good. Okay, so now we have a simpler problem to solve, right? This is a kind of a complex thing to do, but this is a lot easier. F prime of 5, that's simply asking for the slope of the F graph at 5. So we have to shift over a bit here. I need to find the slope of this F graph at 5. Any idea what the slope of this line segment is, or how we can find the slope of this line segment? It's not quite 1/2. I think we may need to pick out points that lands at an intersection. Wait, is it 1/2? It is 1/2, isn't it? Oh, thank you. Sorry about that. I thought I misread. Yeah. So it's 1/2, right? So if I pick a point here and here, up 1/2, or if I pick a point here, that works too, up 1/2. Okay, yeah, 1/2. Okay, G prime of 3, we're going to go to 3. What's the slope of the G graph at 3? Yep, up 1/1. Okay, do we need to do another one of these, or you think you're okay? Good, you're good. Okay, so let's turn to a more traditional problem. Page 13. Why don't we do a problem like number 7 here, asking for the derivative. Maybe you don't know all the rules involved, but what is something that we can do as our first step? What can we do to maybe get this a little bit cleaner to work from? Yeah, let's rewrite that's the radical here. So okay, so once we have the parentheses in place, we have to ask ourselves, is this something that I can expand or distribute or Yeah, well, if we factor, it's not going to come out clean, right? Multiplies to be 2, adds to be -4. Maybe it would have worked if it was a perfect square, but it looks like we're stuck. Okay, we can't distribute the 1/2. We can't get rid of the parentheses. We can't get it to the point where we can just rely on power rule. This is too complex of an expression to split up and just rely on power rule. So yes?
Why couldn't you just distribute the 1/2?
We can't distribute the 1/2 because then we're breaking rules, okay? Because of the plus and minus. So let me tell you what you could do if the problem was x squared times 4y times 2. This is fair game. You can distribute the 1/2 through all you want and you're not breaking any rules. But as soon as you introduce plus or minus into it, yeah, we have a lot of problems with plus or minus. So a lot of students who would think, that everything is going to be like this, but not when there's addition and subtraction involved. Okay, so that prevents us from being able to do that. Okay.
Maybe like chain rule.
Chain rule, right? So but the first thing we should always do is we look at the problem and ask ourselves, can I just rely on power rule? Can I? We obviously did a radical form, but we can't get rid of the parentheses, right? So that's always a good thing to check. Rely on power rule first. If it doesn't work, because something is too complex or just order of operation doesn't work, then usually chain rule is our next option, okay? But it's always good to get into the habit of checking for power rule, expansion properties. If it doesn't work, chain rule is our next option. Okay, so chain rule. This is a more straightforward problem in terms of compared to the one that we just did with f and g. So visually, what I like to do with chain rule is I like to spell out what the outer function and inner function look like. Right? So what can I do to represent the outside function of this problem? Okay, thanks. Have a good day. Yeah. So this I like to see for myself exactly the two functions kind of broken down apart from each other. So I like that visual perspective because I'm just going to tell myself, I'm going to just take the derivative of that outer function, take the derivative of the inner function, I'm just going to place them next to each other. Okay, so here's my derivative. Outside function, this is a nice clean power rule. It's a little bit strange with that parentheses as my variable, but I'm going to treat that the same way as x to the 1/2. Just go through a derivative, but instead of x, I will use a big gaping space for my variable. Okay, so there's my power rule. What can I fill the inside with? No changes. So this represents f prime of g of x. F prime because that's the outer function, g of x because I'm leaving the inside function alone, times g prime times what? Make sure you put that instead of parentheses. All right, there's our derivative. Our calculus is done, but we can still do a little bit of cleanup, but at least we're done with the calculus. Any questions there? So when I talk about cleanup, I'm thinking putting this all under one fraction and putting where the denominator terms belong and where the numerator terms belong. So the 2 goes below, the parentheses go below, the 2x minus 4 goes above. This is fine. I like to clean up if I can, though. I can take out a GCF of 2, and that can help wipe out this 2 here. You can also change the denominator to a radical. That's fine as well. Okay, questions? I think I have time for one more. Let's go to the next page. Yeah, question? Oh, okay, sure. Okay. Let's do number 14. Okay, this is a combination problem here. This is a combination of different rules. What do you see?
Chain and quotient rule.
Yeah. You see, so what are you gonna say? Chain and quotient?
Yeah.
Which comes first? Wait. We definitely have chain and quotient, but it's the parentheses that's going to help guide our decision. So if parentheses is over everything, we're going to do which first? Chain. We want the rule that affects a larger portion of the problem coming first. So chain is going to come first because quotient is inside the parentheses. That's going to come later. Okay. So first rule is chain. Once we're inside chain, then we can handle the quotient portion. Just for comparison's sake, look at number 12. Do you see how this is also chain and quotient? Do you see how the parentheses is not over everything? So that means quotient rule has a larger impact on the problem than the chain rule does. So this one, we do quotient first, and then chain is going to come inside the quotient rule. I'm sorry. I said it, but I wrote it down. Quotient first. Okay, do you see the distinction here? The parentheses is going to tell us which one to do first. Okay, so number 14, you said chain rule first. So if we do chain rule first, that means we want to identify the inside outside, right? What's the outside portion? Or cube, right?
Oh, yeah,
Yeah.
I was thinking of it.
And then, oh, okay, got it. You're jumping to the derivative. Okay, so inside function here. Okay, so outside first. 3 parentheses squared. All that's going to go inside is going to be quotient rule, right? F prime g minus fg prime all over g squared. I didn't give myself enough room. Do a little bit of cleanup. We can distribute the 6x through, distribute the 2 through, combine all the like terms, and then we're going to try to push all this together under one parentheses. Sorry, under one fraction. Okay, I'm skipping a lot of steps here. Ultimately, I'm distributing the 6x through, cleaning all that up, distribute the negative through, distribute the 2 through, clean all that up. All that messiness is going to come out to be just this. All right, what goes in the denominator? Okay, so let me point something out here. This here, let me rewrite this. Maybe this will be easier to see what's going on here. This is really 3 times 3x squared minus 2 squared over 2x plus 3 squared. All right, are you guys in agreement that these are the same things? So maybe it's helpful to just split them up so that we can force us to see that 2 impacting the denominator. So now it's a little bit easier to see what happens, right? This is really raised to what power when I merge these together? To the 4th, yeah. Because if I break this into its separate parts, do you agree that this is really 3x squared minus 2 raised to the 2nd power, all over 2x plus 3 raised to the 2nd power?
Oh, yeah.
So this is really raised to the 2nd power. And this is also raised to the 2nd power. So if I merge these together, I should be getting the 4th power. But it's hard to see because that 2x plus 3, that 2 is so far away that we think it's only influencing the top, but it's also squaring the bottom as well. So a lot of us just say 2 plus 1, but we forget that 2 there, so it should be 2 plus 2 equals 4. Okay, we can pick this up tomorrow morning. We can maybe hit some of the other problems up there on the board. I hope to give your quiz back tomorrow, but we'll see. I'll try to do that.